Okay, anyway, so, all right, I'd just like to welcome everyone to today's talk hosted by the Transportation Society. Topic of today's talk is using BIM to manage highway flooding, and it will be delivered by Paul Campbell, who is a solutions engineer with Autodesk Water. Paul's a technical sales SME for Autodesk, specialising in storm, sewer, and flood modelling with InfoWorks ICM and ICM Live. In his role, he advises customers on modelling with InfoWorks ICM across the EMEA region and regularly presents at conferences on the subject of hydraulic modelling. Before joining Autodesk, Paul worked in consultancy since 2002 on a wide range of water industry and flooding projects, focusing primarily on hydraulic modelling. So, without further ado, I'll hand over to Paul. He can get started on his presentation. So, over to you, Paul.
Thanks very much, Alan. And just remembering how Zoom works, I'll just be able to share my screen there. So hopefully you can all see this. Yes, a little bit of a mismatch with the titles. I've been tackling highway flooding with InfoAsset Manager and InfoWorks ICM, but it's not a million miles away. There are elements of BIM in it. If you're the BIM manager on the call, I'll try and accommodate you. But the focus is going to be around that flooding piece. And who am I? Why should you be listening to me? Alan's just covered most of it. I've been doing some form of water engineering since 2002. I joined Autodesk back in 2020. I actually joined analyse, which was bought by Autodesk. And I specialize in InfoWorks ICM and ICM Live for hydraulic modeling. And then just because we always like a little personal touch on these, I do lightsaber dueling in my spare time, and I die a lot. So just for a bit of fun. What am I going to talk about today? A bit of an overview of us. So I'm sure everyone's heard of Autodesk, AutoCAD, Civil 3D, but a little bit of an overview of the water infrastructure piece. And then I'm going to talk about asset management. This is your BIM piece, knowing what's there, what's in the ground. It's a big problem, especially with underground drainage. People build a road, build drainage, and no one remembers what's there until it goes wrong and something floods. Then talking about how you can turn all of that asset information into a model so you can get useful information, useful predictions out of it. And then moving into the live digital twin piece of automating that model and how you can get automatic flood alerts. So I will not spend much time on this bit first, but the corporate bit of who are we. So here's a quick potted history of us. So you may be familiar with tools like micro drainage or InfoWorks ICM. All of this bottom history here eventually came along to us joining Autodesk in the early 2020s. Autodesk, obviously, long history with AutoCAD, Civil 3D, all that sort of thing. So this is the history of us and our place in the water industry. And what our vision is to be able to help people out through the whole water asset management. So from planning, design, building that asset, and then operating and maintaining it. So a lot of what I'm talking about today is going to be in this space here where you've got something already built, it's flooding, what do you do about it? So here's the Autodesk water infrastructure products. What we do today, I'm going to be focusing on this piece here. So the asset management piece with InfoAsset Manager and the storm, sewer and flood piece with InfoWorks ICM. I don't think we covered it at the start, but if you do have any questions, feel free to drop them in the Q&A box as we go along, and we'll have a chat at the end. Alan and Hugh will pepper me with questions, and I'll do my best to answer. My first question to you, see if you can recognize that. No doubt there's someone on the call who probably was involved in designing that, but everything starts with an asset. So asset management, particularly around long-term assets. So things like drainage, where you can put it in the ground, it can be there 100 years later. Roads, you're looking at 40 to 60 years easily. Buildings, all of these things, commonly called BIM these days, but everything starting with that asset data, what was built, what's in the ground, and what sort of condition it's in. How does it operate? So these are the things. InfoAsset Manager is an asset management tool designed specifically around the water industry. So it's got lots of inbuilt functionality for managing pipes, managing how the water industry works, so how drainage works. I'm not going to talk about, I'm not going to read out everything on screen, but it's a way to integrate all of your existing data, whether that's from GIS, models, survey data, all in one place so that you can very easily keep a handle on what's going on with your underground assets. Here's how it's configured. So you've got all of those different data sources, GIS, SCADA, asset registers being the main one. They can all come into InfoAsset Manager. And then there's two other modules as well. There's InfoAsset Mobile and InfoAsset Online. So InfoAsset Manager is for your BIM manager, your asset manager, so that they can do lots of detailed workflows on the asset. They can do things like integrating survey data with the assets so that they can line up where a defect found in a CCTV survey actually is on the pipe in the ground. They can also do risk-based prioritization. So if you've got an underpass that regularly floods and causes that road to be impassable, that might be a high risk prioritization. If you've got a road outside of a hospital where it's really important that the ambulances can always get in and out, that's going to be high risk. If you've got one pipe where if it collapses, the entire town is going to be underwater, that's your high risk. So all of these sorts of things, as well as the age and the condition of the pipes, can be built into these risk-based prioritization tools. And it's all about leveraging your existing asset information to give you the best possible outcome. So this is a screenshot of the software. It's all built around a single database. So you can have all of your information for your SUDs, flood defenses, pipes and drainage, all in the same place. You can set up themes in the same way you'd have drawing views in your CAD. You can have different themes to show different things to different people, and you can put it all in the same place. There's ways to automate lots of things. So you can automate data transfers with the GIS, so you can pick up all the latest updates. You can bring in the CCTV data, and you can also control work orders and things. So if you need to push work out to a team on site, you can push that out to them. And that's where it becomes the integrated workflow between the office and the field workers. So quite often, a lot of these assets, they were built in the 60s. All of the paper records have since been lost in a shed somewhere. This is an issue worldwide. It never got digitized. So you find out that half of the things below ground you don't even know about. You need to go out and survey them. You need to go out and do rehab on them. So within the software, you can push automated workflows and work orders out to teams in the field. They will get a detailed location, detailed map, lists of all the work they will need to do, forms to fill in. They can work completely offline, and then when they get back to some sort of mobile signal, Wi-Fi signal, they can upload all of their results, and it can be back with the guys in the office straight away. So they don't have to wait for lots of data transfers and emails going back and forth and reports, paper reports and the like. It can all be done within the digital environment. So just to walk through that, in an example, I apologize for this being Scotland, but that's what my icon was. But you can have your guy sat in the office. He's saying, I need to look at this asset. I need to look at the manhole. I can embed the standard operating procedures, any health and safety information, any traffic calming measures that are going to be needed for the work. Guy in the office can plan all of that before they even go out on site, before they look on site. They can even do things like look at the link directly to the Google Street View, so they can see exactly what's happening on site. So before the engineers even arrive on the site visit, they've got a good idea of what it is they're going to look at. So they can very quickly and easily find this manhole. In this case, the man here is looking to do a survey of this manhole. They can understand any historical visits that have already been taken place, so they can have the records there of what was in place. All of this building up the picture so that they know it's going to be safe when they go out and do their work. When they do the work, they can initiate that work order by clicking on the map to say the asset's there, it's been created against that work order. They can have all of their asset information at the fingertips, and then they can do their updates. So in this example, we've got what looks like a new build, a load of new houses. Obviously, they're drained somehow, but there's nothing in the records. So they can go out, they can do surveys of each of these on their mobile tablets, include it all in, and have it set up. That's just a reminder for me to switch over to the software so I can show you what it looks like in the real world. So this is a quick example. Hopefully you can still see that. Let me know if you're still seeing the slides or if you can see the software. So we can have this database open here. So as I say, this can have all of the information. If you're a large organization, lots of things in, you can organize your data however you want. You can split it up by north, west, south, have lots of different folders, or you can have something called a Geo Explorer. This can be themed up however you want. For the sake of a demonstration, I've kept it simple. And in this Geo Explorer, this is like a mini map that you can link through. So if I click on the east, it will open up the data for that east region here. If I click on the south, it takes me to the south. And you can see here, I've set up lots of themes in the south region for this map. So this is a straightforward, this is my asset data. I've got my manholes, I've got my flooding. I can drag in my ground model from my LiDAR. So I can see exactly what's going on. I can see here I've got some incidences, so I can click on those incidences, see what it was, what the problem was. This has been closed, so don't care about it anymore. I can look at these pipes. I can see all of the information about the pipes. In the past, that's had some work on it, being pipe cleaning. I can look at the road. I can look at the pipe information and see lots of things like the dimensions, what it's made of, everything I might need to know. But more interestingly, I can theme this up. So if I need to look at the flooding severity index, I can theme that up so I can see where the regular flooding problems are. I've got these themes set up. Flooding frequency on the road, again, I can look at these themes and see what the color coding means. Any outfalls along there, I can see the criticality of that. So I can point out where my critical outfalls are. So we've got issues around here, strangely enough, right next to our flooding location. If I want to bring on with the ground model. And then if I want to really get into detail, or if I want to share this with someone who's maybe not as au fait with the digital information, I can bring up a 3D view and look at all of this. I'm just going to reopen that and have a slightly better 3D view. If I go here. So we can zoom in here. We can see here, we've got drainage on the overpass there, connecting down to this ground level. So we can see in quite a lot of detail exactly what's happening, where we are, what's going on. We can include on the ground model and things if we want, but you get the idea. It becomes a very powerful visualization tool of what your assets are, how deep they are, what they're doing. So that's InfoAsset Manager. If we then want to go the step further, we know what our assets are now, we know what the problems are. We want to make predictions. We want to turn this into more useful knowledge. That's where InfoWorks ICM comes in. So ICM stands for Integrated Catchment Modeling. This is a way to bring in below ground drainage, any surface waters, so things like rivers and bridges, and any fluvial, pluvial, any sort of water interactions you want to include, they can all be brought into InfoWorks ICM. So once you're fully aware of what your asset data is, you can include any river models and everything like that. You can then use that to build a model. These two softwares can be used independently. You don't need to use them on your own. This is obviously an idealized workflow. If you've got everything in InfoAsset Manager, you can share a database with the modeling to make this as easy as possible. But with InfoAsset Manager, this obviously, panic moment as my video didn't play and then it started. If you've got the asset data, this is just an example video, exactly as I was showing you. Got a small town there. That's all the asset data. If I want to turn that into a hydraulic model within InfoWorks ICM, I just press a few buttons and I've created that hydraulic model from there. So we can see there we've got all of the links information is in the model. So then we can turn off the asset data as a background network. We can keep it on if when we're building the model we want to look at that asset data, but then we've got a functioning hydraulic model. So the difference between the asset data and the hydraulic model is the calculations you can do. So this is where we're running simulations. As I say, they'll work independently. So if you're not using InfoAsset Manager, you can import data from GIS, other models, even CAD data. You can import all of this into InfoWorks ICM. The example on the video there is importing in infradrainage. You may be familiar with microdrainage, was one of the standard drainage design tools. Infradrainage is the successor to that. We can import all of that into ICM as well. As you can see, you can import DWG. So if you've got any CAD data, you can import that in as well. All to help build up the most accurate hydraulic model you can get. So, as you can see, GIS data, background maps, everything like that can all be brought in. Sometimes you get data missing, so things that'll be fine in the asset data. You don't necessarily have to have all of your invert levels as long as you've got the majority of them. But we make sure you can visualize all of that within the software. So in the model now, if I select a pipe on the geoplan, it's going to be selected in my long section. It's going to bring up the property information as you've just seen in InfoAsset. But we'll start to get things like these inline data flags. So this tells me where the information's come from. So whether it's from GIS, whether it's just a default in the software, whether it's someone's initials of the person who input the data. And we also get these validation flags, which is going to tell me that the model simulation isn't going to be able to run. Fortunately, we've got inference tools that'll fix all that. And then once you've got it, again, visualizing everything. So hopefully that video is going to play. But this is where it really comes into its own, because you can show the flooding to people. You can explain exactly why that flooding's happened. And once you understand why it's happening, you can start to look at ways to fix it properly. So while the people who are going to be complaining, quite rightly, are these people here, the problems are actually starting all the way up here in a different part of town where the drains are getting completely overwhelmed and flowing overland to that low spot. Obviously, within the model, you can interrogate everything, you can graph everything up. But again, going back to our example, if I switch software again, this time I'm in ICM. So you'll see here, same database, we've got the same things, we've got the asset information here. So I can open up that same piece of asset data. This is the road. And in the same way as that video showed earlier, I've created a model from this. So looking at where my flooding locations were, I just zoomed in on this part here, and I've made a hydraulic model of that little area there. So if I open the model up, always the way when I try and do a live demo, this is where it will take its time to try and open things from the server. There we go. So I've made a couple of sections of that asset data into a hydraulic model. So again, if I bring on the ground model just to show you a bit of context, what we've got is this area here is a 2D zone. So I've made a mesh of lots of little triangles based on that LiDAR data. I've imported in the pipe data to create a model. And you can see, if you want, the history of what I've done with that model. So if I show my commit history, we've got all the details of each step I've done. So I've created it, I've created a 2D zone, I've changed the coordinate system, I've remeshed it. So you've got that history there. The advantage of this now is I can throw rainfall at this. I can see what's likely to happen. So we know from our themes here, these are known flooding locations. We know this is where the problem is. So in here, I can look at different things. So what I've actually done is I've run a couple of simulations. I've run one simulation at a 1 in 1 year return period with 30 minutes duration, 600 minutes duration, and a 1 in 100 storm. And I've done that without any drainage network in there. So I can open these. If I look at the 1 in 100, 30-minute storm, I can open this up. Oh, Zoom's eating into my bandwidth. But I can open up these results and I can see the impact of any flooding without the drainage network there. So I've got a theme in here, which if I look at the properties and themes, we've got the depth fairly standard, looking at the darker blue, the deeper depth, and I can see velocities on there as well. So just without any drainage network in there, I can maximize these results and I can see the problem areas. So where you'd expect around the underpasses, we've got lots of high velocities. We've got flooding areas here. I should have a background map on here, but again, the problems of live demos, I seem to have lost my Esri connection. But again, if I wanted to see what this looks like in detail, I can view online. I can go directly to that in my maps of choice or a street view. So if I want to look at this and see what's going on, I've just missed the road. I'll move over the road. I can see what's going on there. I can see where any drainage gullies are, what the issues are likely to be, where the flooding is. So I know from looking at this historically, there's issues around that culvert. But then I can bring in, if I look at instead the one with the drainage network, I can start to see the differences. I can see the impact of that drainage network. And again, just opening that, downloading it from the server. Again, I can play this through as a video or I can maximize it. So if I just quickly maximize the results, I can also graph any of these things. So if I want to quickly graph the flow through this culvert, I can see that. And because these are live results, I can take that to the start, I can drag it to a certain time so I can see any specific times within there and what's happening. So I can see I'm still getting flooding onto my road, but it's not causing too many issues there. I want to go up and look at the other area. I can see where I'm getting large amounts of flow onto the road, issues around this impromptu watercourse, probably just a drainage ditch coming onto the road and causing flooding at this local low spot here where the drainage can't deal with it. So that's where we can start to use the model to develop new solutions. I can quickly go into my model. I can test things like upsizing pipes very easily. Just for a bit of future looking, we do have it on our roadmap that we're going to include automated design tools in here, so you can automatically upsize pipes and things and adjust ground levels and the like. So again, back to the slideshow. This is where it gets really interesting. This is where you can automate it. So there's an add-on for ICM called ICM Live, which is all about automating these flood alerts. So once you've got your models built, if you've got any known problem areas, you can incorporate live weather data, any live sensor data you've got, even things like river gauges, if they're in place. You can incorporate all of that to give yourself automated flooding alerts. What this does, it takes the model away from people just using it for planning and development and makes it really useful for these operations teams and the field crews. So a typical workflow might be you're starting with asset data in whatever format, you're using that to build your model and you're understanding your problems, doing your planning, and then taking that through to get the buzzwords in, making a live digital twin, an operational model. That can then feed back to the operations team. So a whole thing might look like this. And in case you're wondering what use this can be, obviously there's the live flood alerts, but it can also take you to proactive management rather than reactive management. You can start getting plans in place ahead of a major storm. So rather than just thinking, oh, there's going to be big heavy rainfall, we're expecting some problems, we'll get the teams ready. We can start to think, I know I'm going to have flooding at this location. I'll go out, I'll put up some flood barriers, I'll put up some signs, I'll make some diversions ready. So just for some real world examples, this is an honest example of operational planning that was used. They had 2 drainage pipes. They needed to do a bit of repair on this work. Old brick pipe, bricks had collapsed. There was a structure in place where they could do flow diversion. So using the ICM model, they said, what happens if we do that diversion? Can I get away with this? And the model said, yes, you can, but only in mostly dry weather. If the rain gets too high, you get flooding upstream because what essentially was going through 2 pipes is now going through 1 pipe. The solution, they used the 5-day forecast from ICM Live so that they could pick out and schedule the work days. They said, we want a solid 3 days to do this job. Use that long-term forecast to schedule the work days. But they also put in a short-term ICM Live forecast. As you can imagine, the weather forecast for 6 hours time, very accurate rainfall. They can use that to alert the work crews. So rather than your standard underground working where you maybe get 15 minutes warning that the water level is going to rise, the work teams now have 6 hours safety warning to say, we're expecting this is going to get dangerous below ground, get out of the drainage network. That gives them the time to tidy up the tools, get things safe, get things racked away, and they can get out. It also does the very clever thing of if the weather forecast changes, it will cancel these alerts. So you can then get back to work. So that's the small scale operational style of this. On the large scale, this is the largest implementation I know of ICM Live. This is the island of Tasmania off Australia. So quite a large scope. Well, actually, what SES is their combined, it's the organization of all of their emergency services. So this is the police, the fire brigade, the ambulance. They all got together and commissioned their own flood maps. So they used ICM to create detailed flood maps so that they could respond in emergencies. And then they took the next logical step of turning this live. So this isn't a public system. This isn't even a highways agency or a water authority. This was the emergency services saying, we want an emergency flood map. So they've now got these live flood maps so that they can plan which roads are going to be closed if there's a major flood, if they have an Arctic storm, I suppose it would be down there, coming up, hitting the region. So this was a response to some very bad flooding they had. They can then have this in place. They can use it for public warnings if they need, but more importantly, if they need to get out to these remote areas, they know which roads are going to be blocked. They know where they're likely going to need to send emergency crews. And that's it. I think I'm more or less perfectly on time